Hello to all of you. Those who are new to the channel may not have understood what our goal is. For a while, I have been making solar dishes, and for a while, I have been making steam turbines, and now it's time to make generators. In fact, the real goal is to be able to build a unique home solar power plant. And in this way, we want to be independent and make all the main parts, such as solar dish and turbine, by ourselves. All the contents of our video are true and there is no fraud because our goal is higher and fraud will not have any results and will cause a waste of time and money of the viewers. Today I want to discuss how to make this generator. The long length of this generator allows more magnets to be placed in front of the coil. We will see how to make it later. Of course, the power of this generator depends on various factors. The most important of them is the use of a strong magnet and increasing the number of turns of the coil and the thickness of the wires and the close distance between the coil and the magnet. Let's go see the video. Let's assume that we don't know anything about Faraday's laws, but with a simple experiment, we can understand many of the laws of electricity and magnetism. I am doing the experiment with this coil which is related to an electric motor. Of course, it is a 220-volt electric motor. I use a zero-center galvanometer as you can see. Now I connect the output of the coil to the galvanometer. If I have a permanent magnet, you can see that by bringing the magnet closer to the coil, the current created by the galvanometer is shown. The closer the magnet is to the coil, the more current it generates. And in this distance it has less effect. And the closer it is to the coil, the better. Now one more point. If you look carefully, the direction of twisting the wires is like this. And now if I turn the magnet 90 degrees, you will see that the movement of the magnet has no effect. So, in this case, it creates current. Now I want to bring two magnets closer to the coil from both sides. First, in the case where both magnets agree with one pole, you can see that we see more flow. Now, if one side is the S pole and the other side is the N pole, you will see that the current will decrease drastically. So the two sides must be the same pole. Now I use a stronger magnet. You can see that a stronger magnet has a much greater effect. But unfortunately stronger neodymium magnets will be much more expensive. You can see that if the direction of the magnet changes, the current will be close to zero. Of course, the diameter of the coil makes the intensity of the magnet's magnetic field less effective on the internal wires. In fact, the magnet has a greater effect on the top coils than the inner coils. Now we perform the test on a coil that is placed in the generator. This is a stator of an electric motor that uses two coils facing each other, and if it is used as a generator, the magnet inside must rotate. This coil has 300 turns. And if I move an arc-shaped magnet on it, you will see that the galvanometer moves. One side is the S pole and the other side is the N pole. You can see that this iron washer is the size of the coil ring. If we do this with two stronger magnets with two identical poles located on this iron washer, the movement of the galvanometer will be less. Now if I change one side to S pole and the opposite side to N pole, you can see that it will have a great effect. Therefore, in the generator, the rotating movement of the magnet is from one side to the other. And this is different from the movement of the magnet approaching the coil from both sides. In this type of movement, unlike the magnet movement in normal generators, both poles must be of the same name. Now, according to these points, we design a generator. I use a PVC tube. I put the cut pieces of wood on this pipe like this, and I will coil around it. The length of this piece of wood is 30 centimeters. In fact, with this work, the diameter of the coil is reduced and we put more magnets in front of the coil. First, we need to determine the cross-section of the pipe on which the coil is placed. This hypothetical circle is the desired pipe section. This circle should be divided into 16 equal parts because it contains 4 coils. I mark the points that contain the coil. You can see that this coil is in front of this one and this one is in front of this one. Now, according to the plan, we have to divide the surface of the pipe. The outer diameter of the tube is 75 millimeters. That is, we have to divide the surface of the PVC pipe into 16 parts. First, we calculate the circumference of the cylinder and then divide by 16. So each part should be 1.47 centimeters. First, we draw a line along the cylinder with an iron corner. And then we mark a distance of approximately 1.5 centimeters with a meter. Now we draw all the lines with the same iron corner. Now the cylinder is divided into 16 parts. And the wood should be placed on the cylinder like this. Now, since the length of the cylinder is 40 centimeters, we will mark it as 5 centimeters on both sides. Now, in order to place the wires in the desired place during winding, we cut the ends of the sticks in an oblique manner. I use 1-2-3 glue to stick the wood on the surface. The advantage of these adhesives is their adhesion speed and strength. The disadvantage of these adhesives is that they lose their adhesion against heat, and the presence of moisture and water gradually destroys its adhesion. According to the figure, the next wood distance should be in the fourth area. These two cross sections are one coil, and this is another coil, and this is another, and this is another. I glued this part with wood. According to the figure, the next wood distance should be in the fourth area. So 1, 2, 3, and 4. Now I'm going to start coiling. I am using this type of wire, and its diameter is 0.4 millimeters, and if its diameter is larger, it will be much better. I wrap 100 rounds of wire around each stick, which won't take much time. It took about 7 minutes. The previous winding direction was from this side, and for the next one, the winding direction must be opposite. Now we specify the directions. This is from this direction. Now I have selected a PVC pipe with a smaller diameter than the coil pipe and divided it into 16 equal parts. And this PVC pipe can easily move inside the bigger pipe. For the PVC pipe cap, I used a thin wooden sheet and made circles for both sides of the PVC pipes with a laser. I have done this with laser cutting, and of course other methods can be used. Rectangular pieces of wood are intended for the placement of magnets. If I put this here, it's 30 centimeters long and has 1.5 centimeters of space on both sides. The magnet is placed on both sides of it. Now it's time to glue the magnet on both sides of the thin wood. I have prepared 100 neodymium magnets which have weak magnetism due to their small size. The strength of the magnet is very important, but let's see how strong our generator will be with these magnets. The magnet should be placed on the PVC pipe like this. For convenience, it is better to put an iron pipe inside the PVC pipe. This part was on the end side that we stuck here, and if I turn the magnet handle upside down, it will be on the S side. I glued all the magnets. One side of the N pole and the other side of the S pole. Our generator rotor is ready. You can see that the connection between the coils is established. Now we will test it. We put the multimeter in the AC voltage mode and connect it to the output. If I turn it by hand, the output voltage will be approximately 3 volts. Now I turn it with a drill. It is interesting, and it looks like it has a regulator, and the voltage remains constant at 23.3 volts. Now I will connect this SMD LED chip to it. If we increase the number of turns of the coils, the voltage increases. And increasing the diameter of the wires will increase the current of the generator, which is very important. And using a strong magnet is very important and multiplies the power. The small distance between the magnet and the coil is also important. A generator made with a permanent magnet should spin hard when connected to a load, that is, the generator power is adequate. I hope you have a good experience. Bye until the next program.